I'm going to share my screen. Let me remove this code and then, yeah, okay. All right, can everybody see my screen here? Wait, I think there we go. Okay, can everybody see this? Okay, great. So we're gonna go ahead and start here. Let me do just one more thing, if you guys don't mind. Sorry, hold on. I'm doing something on my laptop. Okay. All right. So this is going to be going over forking, and for this part here, I'm going to go kind of fast because I don't want to spend too much time on it tonight, but this is pretty much what you're going to get on your extra credit tomorrow. Everybody's going to get a relatively different question, and you can learn how to read this, but honestly, it's better to just focus on this, right? So this is going to be the main thing here. So basically, if you don't know what forking is, it's like creating child and grandchild processes from your program. And so this is going to be your instructions on what you need to do, okay? So we have here, and it is sequential. So if we have a parent process, and then we have a child process 0, and then we have a child process 1, and then we have a grandchild process from child process 1, and then we have a final child process 2. That means you're going to create a parent, create a child, create another child, then create a grandchild, and then create another child, okay? And I'll show you how to do that here. So if we go ahead and start doing that, I don't have Ubuntu working on here right now on this computer, so it's going to say it's not working, but it'll be the right code. So starting off, this is pretty much exactly what it's going to look like. You're just going to have your cout statements, and yeah. So when you run a program at first, like on main, it's always going to be the parent process. So you're going to cout, and you're going to say, I am the. There's always one. Ollie, can you please find that? Thank you. So you're going to cout, and you're going to say, I am the parent process. And this is just going to be for the first one, right? Because you're running the program, and because you're running it, it's going to make you, this is the parent, right? And so now, all you really need to do is, I would just create the amount of loops, like create a loop, and its iterations are going to be the amount of child processes you're making, okay? So if we're making 1, 2, 3 child processes, then all you got to do is just say for int I is equal to 0, right? While I is less than 3. And then we'll just say, we'll say like I++. Sorry, I'm like doing reference code here. And now what we can do is, this is where we're actually going to create our forks, right? So we're going to say integer PID is equal to fork, okay? Now, as soon as this is called, this is where the fork is being initialized, okay? And fork returns 2 things, okay? It returns a 1 or it returns a 0. If it returns a 0, it means it was successful. It means good job, you have successfully forked. If it returns a 1, that's a bad job, okay? That means you have not successfully forked, okay? So most of the time it's gonna say 1, but just in case, we're gonna double check, okay? So we're gonna say if PID is equal to 0, so if we have just successfully forked, now we are inside our child process, okay? We are currently inside our child, so we're at the parent. We're going to fork 3 times, right? And then we're going to, I'm sorry, this is supposed to be a 2. And then we're going to fork, right? And then, wait, I'm stupid. This is supposed to be a 3. I don't know why I can't do basic math. And then we're going to fork, and then if it's successful, now we're inside our grandchild. So now you could do your cout. I am the child process, okay? And you'll notice here that the child process takes in a value. And all you have to do for this value is just say it's equal to I, right? Because if I is 0, then and we fork, then it's successful. We're going to say we are the child process for 0. And then it's going to do it again. And we're going to say, well, I'm the child process for 1, and then for 2, and so on, right? So, dude, I don't know why my brain is not working today. I'm pretty sure this is supposed to be 2. I'm sorry. I just am confused. Okay, so now when we have our child process, right, for 1, 2, and 3, right, then what we can do here is we can check and make sure if some I is what we need, then we can make a grandchild, right? So if this says we are a grandchild process from child process 1, then what we can do is we can create a grandchild process. Now, there is something you have to keep in mind when you're doing your forks. Every time you do a fork, like every time you successfully fork, so after you have checked for a successful fork, you need to wait, okay? You need to call this wait function here, and we need to put a null pointer in there. And the reason we do that is because this makes sure that our processes are synchronized, okay? It keeps them synchronized. So if we didn't have this wait here, when we fork, it might print out the child process at 2, and then, and then 3, and then 4, and then 5, and whatever, right? And so, yeah, so basically we're going to, oh, I know why I'm so confused. I'm sorry. I'm looking at 2 different examples. I'm looking at this one and then the one on my other thing. Okay, I'm sorry. And then this should be, okay, yeah, sorry. I'm looking at 2 different things on here on my other screen. But yeah, so basically this is going to make sure that we're synchronized, okay? So a little trick is every time you call fork, check if it's successful, and outside of its if, always put a wait, okay? Always. That's all you got to do, all right? Now, there is going to be another condition that we have to call here in a minute, but we'll worry about that in a second, okay? So after we have created the child process, we can now continue to create a grandchild, but you'll see here we only want a grandchild for process 1, okay? We don't want a grandchild for 0 or 2. So all you have to do is just say, look, if I is equal to 1, then we can fork again, right? So then we can do PID is equal to fork. And again, after you fork, you have to make sure it's a successful fork. So we can check if PID is equal to 0. Then we can go ahead. We know it's successful. So now we have entered our grandchild process. Okay, I am the grandchild process for space, and then we'll just say I, right? And now we have created a grandchild process specifically when I is 1, which is what this will do here, okay? And now, again, we have to make sure after we have fully checked to make sure that this is good, we have to wait to ensure synchronicity. And then we have to make sure we leave these processes, okay? We have to make sure we leave these processes. And this is a very important thing to do, because if you don't, then you're going to get stuck in these processes forever, okay? You're not going to have stableness in your program, okay? So how we get out of these is after we have printed this out, just get in the habit of calling underscore exit, exit 0, because that's all we need this process to do, right? Once we have forked and we have created a pipeline to the grandchild process, we can leave it after we've done our printing. We don't need it to keep running, okay? And so if we exit here, we're also going to need to exit out here right before our, let me tidy up these here. right here, okay? And we need to call this exit because of this child process right here, okay? So if you want to look at it from a technical standpoint, right, all it is we're just saying, look, we're starting at the parent, and then we're running, and then, oh, we call fork. So we call fork, so we branch off, and we're actually going to be calling fork 3 times, right? So we're going to be calling fork 1, 2, 3 times, okay? And then look at it from a linear standpoint where we go here, and this is the first time we've called it. So it's at 0, right? So then it's going to print out I'm the child process for 0. Is I equal to 1? No. Okay. So then we exit out of that child process 0. We exit out because none of this is getting called, right? Because I is not 1. So we exit out. Okay. And then we're going to go back through our iteration. We see that there is a 1. Okay. So now we have 1 here, and we're going to create the child process for 1. And then is I equal to 1? Yes. Okay, great. So we're going to fork again. Okay. And if it was successful, we're going to make sure that we say that we're the grandchild. Okay. So now we fork again and we create a grandchild. And once we've printed that out, we call exit. So now we've left that. Okay, we still haven't left this one yet because we're still in here, but then we're going to wait for synchronicity. And now we've reached the exit, so now we're done with that one. And now our loop is at 2, and now we can go down and we can say, I am the child process for 2, right? And is I equal to 1? No, I is not equal to 1. So now we can print out I'm the process for 2. And then we're going to exit, and that'll be it. So your output will be this exact one here. And we can go ahead and test this actually in here. So we'll test it in here just to make sure it works. Oh, okay, well, I using namespace std. Okay. And yeah, we have parent process, child process 0, child process 1, grandchild for 1, and child 2. It's going to say it's wrong because the spelling, but you get the idea, right? So it does work perfectly. And so, yeah, final tips. Again, not trying to take up too much of our time here, but final tips are whenever you fork, make sure you verify the fork with if PID is equal to 0. And once you verified that, right outside those if statements, you can make sure you wait and put a null pointer for synchronicity. And then after you have successfully forked at the end of whatever you want to do with that process, make sure you exit, okay? So we fork, we've successfully forked. We're going to say that we have. We're going to check if I equals 1. It does not for this case. And then we'll leave, and then we'll wait, okay? So you could see now, real quick, this is what happened to some students last year, and they actually got pretty upset with some of the TAs. They said it was our fault that we didn't catch this, but they wrote the code wrong. But essentially what it was is one time somebody did this. They did fork, right? And what they did is they called exit right here. They called exit right there after they forked. Or they'll call exit right here. Now let's take a look and see what happens when we call exit right there. It just stops, right? There's no way you can really mess this up so long as you test your program, but sometimes it happens. And you want to make sure that you're calling exit and waiting at the same time. If you forget this wait on this first part here, let's look what happens. You'll see we have 1, 0, 1, 2, and then the grandchild gets put down here, right? So we need to make sure that we put a waits in all the same places, and we need to put our exits in the correct places too, okay? So does anybody have any questions? Uh-huh. Okay. Yeah. Mm-hmm. Yeah, you can do that if you want. If you don't want to do the weights here, you're more than welcome to do that there. That's fine. That's perfectly acceptable if you want to do that. Do you get points off for spelling errors? It's a programming course, so I mean, like, I don't really understand the question too much. I guess no, but like the only reason this is wrong is because I have for instead of from child process. I'm saying for. Like I'm not. I mean, I'll change it. What? What? Okay. Here, let me check it now. Okay, well, yeah. So yeah, see how I do have some typos in here. I don't know what. I'm too lazy, um, but yeah. So technically, you will get points off, I guess, if you don't do it in this exact way. Just has to make sure that this is right. But he's gonna go over it. So if he sees that you got it right, then he'll give you points. Okay. Are you no. You cannot have a cheat sheet on. Yeah, I might have a white space. You cannot have a cheat sheet on the extra credit. Please don't do that. IMD to IMA. Oh. Thanks. There you go. Okay. Again, this is like literally exactly what it's going to look like. So just copy this. Now let's go over real quick because in case this might confuse you, right? Let's say we want 2 grandchild processes for one. Okay. How would we do that? Well, you just have to make another loop, right? So if you want another grandchild process, then we could say, let's say we need a grandchild process for 2 and for 1. Okay. Then all you would have to do is just check, well, if I is equal to 1, actually, yeah, I mean, let's say we needed 2 grandchilds for 1, then all you have to do is just make a loop right here, okay? You would just make a loop where the I is equal to 1, because he might do that. You might have to do 2 grandchild processes. I doubt it, but he might, and so I don't know. See, yeah, don't do sleep. If you do sleep, your program's gonna break and nothing's gonna work. You have to do wait, okay? And you have to do wait in these. You should do wait in these areas to make it easier, or you could just not do the waits and put the for loop. But you know what? Let's try that real quick. Let's double check while we're here to make sure this works. I've actually never done it. Where does he do it? Like right before the return. Okay. And then what does he do? Just wait null pointer. Okay, let's see what happens. Oh, I put. Oops. Yeah, it doesn't look like that's. Oh wait, he has the weights right here. I don't know why this is. Yeah, I just don't do this. Don't do it. Just put the weights right after the if PID is equal to 0. If you remember that, you'll be fine. Okay. Any other questions? Oh my god. Okay. For example, would it be marked wrong if you hard-coded 1? Oh, I see what you mean. No, I don't think so. As long as you put it in here, like as long as you were to like put it inside the I equals 1 and then you put 1 here, I don't think that's going to be, I don't think he would take it off. But I would just do, I would put a variable just in case. Can I do constant G and then do the loop for the grandchild? Yeah, I mean, it doesn't really matter how you do the loop. That doesn't really matter. You could do any method of looping, of iteration. You know, if you know you're going to have 0, 1. Oh, wait, I see. Wait. I think I see what you're going for here. I wouldn't recommend this because if you have 1, 2, 1, 0, he could think that you're trying to hard code like each number of process rather than just iterating it sequentially. I don't know. I would just, to be safe. Okay, do an example. Yeah, sure. So let's say we needed let's say we needed another one, right? If I is equal to 0, then you would just do that. So if we needed a grandchild, and we'll do it better. If I is equal to 2, so if you needed a grandchild process for 2, then you would just do this, right? And then now we have a grandchild for 1 and a grandchild for 2, right? Yeah, this is going to be the only question. You don't have to worry about anything else for the extra credit. This is it. This is all you have to do tomorrow. And I'll be there tomorrow before class starts, so, you can always double check or whatever, if you have notes or questions or anything. Is there copy paste? What do you mean copy paste? Oh, this problem is on the practice exam 1 practice on 8. Yeah, if you will the exam forking question, there's not going to be an exam forking. This is just for the extra credit. Wait, actually I lied. I actually don't know. There might be. Is there? I don't remember, Ali. Okay. Then yeah. Sorry. Yeah. It'll look exactly like this as well. There's no reason you should not get 10 extra points tomorrow. Like, there really is no reason why you shouldn't. You got to learn it eventually for your exam. Okay. The first exam should be, yeah, it is. Okay. Any other questions, any other things before we, yeah, he'll include all the header files and everything for you. All you have to do is just write the stuff here. Yeah, if you study this exact code, you'll know how to do forking, 100%. If you just study this exact code. And I'll paste this code here. And you know what? I'll just paste it now. Here. There you go. Could you explain the relevance of note 1? PQ is the name of the process? Sure. So PQ1 here is going to be the... Oh, wait. PQ1 is the name of the process. I'm assuming it just means that, like... Wait, what does PQ stand for? I don't even know. PQ... I don't think it's referring to this. I think he's just saying that, like, the, like, name of the process is going to be based on your, like, variable here. It's just, yeah, like, it's just I is going to be the name of your process that you're in, right? Okay. Anything else? Okay. Yeah, your extra credit will not be forking. You're cooked if you don't learn this and then you learn forking and then you go in there. Okay. Why do we need exit 0? I'll show you why. If you don't exit out of your processes, then that happens, right? It just loops forever. Okay. So it'll do the process. You got to remember, like, forking is it is creating a copy of all of this, right? Like, if you're not exiting as soon as it's been called, like, it's going to repeat itself until it eventually finds an exit or a return, right? So that's what happens when you don't exit, is then you end up just looping forever. So make sure you have your exits down. Okay. Can you show how to do second grandchild for child 1? Sure. So let's say we want to create 2 grandchildren for child process 1. Then all you got to do is create another loop. That's it. That's all you got to do. Say for integer j is equal to 0, while j is less than 2. Then we can say j++. And now we can go ahead and do our thing here where we can fork. So we do PID is equal to fork. And then we say if PID is equal to 0. Then we can go ahead and call or say I'm the grandchild process from process I. Okay. And then we want to, of course, exit as soon as we call it. And because we have a successful PID here, you want to call wait. Okay. So if we were to run this, you can see here now we have 2 grandchildren processes for child process 1. Okay. So you just create another loop. That's all you have to do. You just create another loop, you fork, you check if it's a successful fork, print out the grandchild process, then exit, it'll do it again, and then there you go. And this is inside the if I is equal to 1, right? Because if we want a grandchild process for 1, we need to make sure if I is equal to 1, then that's what we're doing. Okay, does that make sense? Extra credit is forking. And yes, you're cooked if you don't know how to do this. Okay. Anything else? And here, you know what? I'll post this example as well. If we want a grandchild, yeah. So it's funny you say that. So the and, well, that won't work if I is equal to 1 and I is equal to 2. I think you mean or is that or? Yeah. Yeah, or. Yeah, that should work. Yeah, that should work. You could do that. You can do if I is equal to 1 or I've been coding in Python. Can you say or? I think you could say. You can't say or? What? Average C++ moment. Okay. All right. So if we do this, obviously it's not gonna make multiple grandchilds, but oh wait, I think I forgot an exit somewhere. Oh my god, there's no control Z. All right, I'm too lazy to rewrite it. Whatever. Bro, I write in like 4 different languages. I don't know if C++ has or not. Okay, I think that's everything. All right. Let's see who's next. Ali, you wanna do the threading?
thread. I forgot to put the semicolon here, my bad. Error creating thread, and then new line. This, and then we do return 1 here, and that should cover all pthread create. So basically what we're doing is we're going to be starting to create threads right before we go into our thread function. And each of our threads is going to be each of the digits. So each own digit in like our first test case of 1 through 9, it'll be its own digit. So it'll be its own thread. So 1 is its own thread, 2 is its own thread, 3 is its own thread. We're going to come back to pthread join later. I suggest doing the pthread create and then going to the thread function and then coming back to pthread create. That's just pthread join, my bad. That's just personally how I did it. So we'll be doing it like that. So let's start filling out the in order function. So the first thing we need to do before we do any logic is we need to dereference this arg pointer. So first we're going to call what data type it is. So it's a struct of arguments. If you remember, this is just our thread data up here. And recall that in here we have a previous, a current, I should have went through that, my bad, but we have a previous, a current, and then an output that's stored within that thread data. So we need to make sure we're on top of that as well and we know what our thread data has. I'm going to go here and we're going to start calling it, or start dereferencing it. So let me do this. And then I think it's like, sorry, I forget, this is the one part I forget. I think it's like struct argue, or it's inside, yeah, it's inside struct arguments, my bad about that, struct arguments, then asterisk, and then the arg pointer so we can dereference it. The whole point of dereferencing is that we can start actually using it and apply our logic onto it. So if you recall, we're going to be checking if things are in order. And the way we do that is that we're going to be looking at it before and seeing if it meets, if it's less than or equal to the one that we're currently on. And if it is, then that's a good number. The current number is a good number. And if it isn't, then it's out of order. So let's start implementing that as well. If args previous is less than or equal to args current, sorry, whoops, then we're going to be printing out, or we're going to be storing in our output. Sorry about that. We're going to be storing in our output. We're storing in our output that this is a good, good number.
Hood.
And then we're going to do toString over here. So remember, we need to include the number within. So if you recall to the question, we need to include the number as well. So we're going to do a toString function real quick and get the current number so we can concatenate it onto our, output. So args and the current number, semicolon. So that's our good case. Now we need to do the bad case where it's out of order. And then we'll do this. Same thing, we're going to go back to the output and we're going to say this one was out of order. And then we're going to do toString and connect it here as well. So let me just do that very quickly. And then let me just double check, make sure everything's fine. So we dereference on the first line, and then we have our if statements doing the actual logic. So the general structure for thread functions, as like a rule of thumb that I figured out on my own, is just that like you dereference a pointer, you do a lot of the logic or whatever it may be, and then you return a null pointer at the end. So the null pointer over here is, I forgot exactly the exact reason why, but the way I like to thought about it is just like it tells the function that, hey, we're done. This thread's done. It's ready to come back and end itself in pthread join. So now that we're done here with the thread function, like I said, we're going to go back here and implement pthread join. Same thing with pthread create. Rincon will sometimes give you like a little bit, but I'm operating under the like assumption that he won't give you anything at all. So just try to remember how to do this. One way that I remember is that for pthread join, we need another for loop. And that for loop will always, that for loop will always be the same size as this for loop over here. So, and what I mean by size, that it'll iterate through the same length. So this one iterates to string num.length, aka the length of our test case. So what I like doing previously is I would just copy and paste, but on the exam you can't copy and paste. Sorry, let me just clarify that you can't copy and paste on the exam. So just go over here and double check that everything is fine with lengthwise. So let's do I string. Sorry about that. I nums dot size. Then we call pthread join here, and pthread join is a little more simple than pthread create. All we do on pthread join is we call the current transaction or current thread ID. Sorry about that, current thread ID, and null pointer over here. And so this is all pthread join is. And for me, the way I'd rationalize it in my head was when the thread's done doing its logic and when it's done and it's ready to be outputted, we have pthread join called so that given thread can end. And so over here, this will just go through the output of each argument. So if you recall earlier, we store each of that thread data inside of separate argument values in that list over here. And so what we do now is we're just going to be printing out the output. So we can try with the first test case. So let me just compile this really quickly. And then ./a.out .txt. And then you see we get good number for 1, 2, 3, 4 because this is printing in ascending order. And so I have some other test cases that Jason made as well. So we'll try those as well. So we have test 2 and test 3 as well. So these should all work. If you guys have any questions, I can also put the test case as well in the chat when I'm done. But that's basically all it is for multi-threading. It's not super duper complex. A lot of it is knowing when to call pthread create and pthread join. So in the main functions, you call pthread create in that for loop that fills up the arguments list. And then you should also remember that you need to do the thread, you need to do dereferencing in the thread function as well. And let me just go through before I open up the floodgates for questions. The most common question, let me just get some out of the way. It's all or nothing for pthread create and join. So what that means is that the programming question is divided up into points for each thing. So first, if it compiles, and if you didn't use global variables, just the basic stuff like that. Especially the no global variables, Rincon will dock all your points if you use global variables. So definitely do not use global variables. But you'll get partial credit if you get some stuff right and some stuff wrong. So don't completely sweat it if it doesn't get the exact output. We're going to be going through and looking to see if you deserve partial credit or not. But basically, it's all or nothing for pthread create or join. So if you did these functions properly, it's either you got them or you didn't. Or excuse me, if you got pthread join and create. The thread function is also a separate thing that he calculates. If you got that right, that'll be some points. But that's basically how the grading distribution works in regards to multi-threading. So that's basically it. If anybody has any questions, unmute. I'm gonna go start looking in the chat room. My bad, I was programming this, but let's start looking now.
It's also we don't grade the exams, so just to clarify, so don't message us about your thread or whatever on your exam. Okay, you're gonna have to email Rincon about it. We don't do any of that. We just do the homeworks. Okay.
Sorry about that. My bad. Yeah. Right.
No, you're good. I just don't want people messaging spam messaging and being all pissed off.
Yeah, that includes because I have office hours on that day, so I'm not gonna answer any questions regarding the test on your test day. I'll only be able to help with other stuff related to the course, so just keep that in mind. But if anybody has any other questions, ask me now. I'm gonna go start and put the test cases in the chat. How much time do you recommend on this programming question? That's a great question. So for this one, generally, considering you have a full lecture length, what I like doing personally is I like going through the multiple choice questions and trying to knock those out in the first, I'd say first 30 minutes, try to knock the multiple choice questions. And then for the rest of my time, I split it in half with the programming questions. Usually I would look at the programming question when I get there and try to just knock it out as quickly as I can. Forking for me was easier. So I'd say for forking, I'd spend about 15 minutes if I absolutely had to, just double checking. But I'd say taking around 15 to 20 minutes on the programming questions is your goal, but obviously you may not get there just because in the test setting it might be stressful. So I aim a little bit higher than that, but personally that's what I would do, or that's what I did last semester when I took the course. Around, I'd say 20 to 30 minutes would be good.
Let me say
try not to
this
spend too much
real quick.
on it.
Rincon and I went over the programming question for y'all's exams for the morning or for the both classes, right? One of them, for both of them, we give you the function, right? We give you what to do. For those of you that took the class before, when I did, or Ali or Jason, right? You had to write this, do the stuff. You remember? You had to write the function to actually do it. Let's say the problem was reverse this list, right? You had to write the function that reverses the list. You don't have to do that anymore. We straight up just give you the function that does the stuff. All you have to do is pass the data and write the thread function. That's it. That's all you have to do. Okay? So I would honestly argue that you don't have to have that much time. Like, you really don't have to give that much time to the programming, not nearly as much as you did in previous semesters. Okay. So just heed that advice as well. It's changed a little bit to where it's slightly easier. But yeah, anyway, back to you.
Also,
Yeah.
Cameron, just real quick, was there forking during the actual exam in the previous semesters? Because I do not recall that there was a forking question.
I don't recall it either, but they're saying there is.
Yeah.
So yeah, there will be, I guess.
I definitely had one. Yeah, I remember last
Oh,
semester after the extra credit, we had a very similar one. So I'd expect
what?
something along the lines.
Just want to get that out there. But yeah.
Yeah, that's why I was confused because I didn't have forking when I did it either.
So like the question for multi-threading on the practice exam. Yeah, so I don't know if you're asking like us, but the multi-threading question that's on the practice exam is similar to an extent to what you'll see on the exam. It'll have the same core principles of calling pthread create and pthread join and knowing how to dereference the pointer and working on thread logic. Can you explain what you mean by global variables? Some of the problems on Canvas do have global variables, I think. Yeah. So any variables that are declared outside of the functions here. So if I do like a iterator or something here, pretend I spelled that out correctly. If I do something here, like here, outside of here, you can't do that. No global variables. No, I think I saw some guy do like define or something like that.
No
None of this is allowed.
constants.
No
Not allowed.
constants. None of that stuff's allowed. Yeah, the defined const. I think I saw that on like an example one time. I remember I asked him, but you cannot use any global variables as an instant zero on that problem.
And I mean, like, really do not use it. Please do not use it. Not even in your PA1, PA2, PA3. Please don't do it.
Mm-hmm. Is there a reason? Ask Rincon if you want a reason. I forget the
I
exact
know
one,
the
but
reason. It's because
in general practice, you shouldn't.
there's no you break concurrency. You break the whole point of threading and forking if you use global variables, because then you're not transferring data between each thread or between each like forking subprocess, right? You're just like holding it in the main and then always referencing the main and always doing everything from the main, if that makes sense.
Hmm.
You're not
Yeah,
sharing any resources. You're not even threading.
exactly. Can I use const at all? I wouldn't. Just don't use. You don't need to use const in any scenario over here.
Should not have to use constants ever.
So
Somebody's asking about macros. Um, do any of y'all know what that is?
I don't even know what a
do
macro
not know.
is.
I don't
Oh,
think you can't
like
use the
define.
hashtag define. No, yeah, don't. Just it's super simple. Just don't use global variables. Sorry, I'm not trying to make it like I'm.
No, it's
I'm
true.
not
Like, just don't write anything outside the functions.
Just don't write anything outside.
Everything can
That's
be
the
done
biggest.
inside the functions. Every single thing.
Exactly. Yeah,
Yeah.
you can.
Nope.
Yeah.
Don't define end threads. No. No.
Just do that.
Don't do
in
that.
just literally, yeah.
I don't care if it's good practice. Don't do it.
For
You know what's
theory,
good
It's just-
practice? Getting an A in this class. That's good practice.
Yeah, like in the question premise over here, you can make helper functions and structs as needed, but honestly, you should not need to make helper functions or structs, especially on multi-threading. You do not need to do that. I think that's just like a way to just overcomplex the problem. You don't need it at all. You can definitely solve it very simply, like how I did here with the in order problem that we had by Jason. Can I do X constant? I wouldn't do I wouldn't do stuff like that in general because the way like yeah, you don't need to do that in especially here for the multi-threading problems. The way it works in Moodle is very similar where it'll just read in the input. You definitely should not you're not going to be presented like the test cases like this in a file where you'll be able to see them. It'll sort of just be like you make your program with the correct logic, with the correct pthread creates and joins, and Moodle will run it and make sure it works. 30 points for this question. I don't know how many points this question is, but what I do know is that the programming and multiple choice is about a 50-50 split. So I would assume that this is around 20 to 30 points. Same thing with the forking.
I think forking's like 10.
Oh, forking's like 10? Yeah, it could be. I haven't checked the test or anything, but I'd assume it's around there.
or maybe
I'm more
15.
scared of theory than programming. Make a good cheat sheet. Honestly, just make a good cheat sheet. I would watch.
That's what I'm
I
saying,
would go
bro.
through the lectures.
The programming is not hard, bro. You should not be scared of programming. It should be the theory that you're like studying. You
I
know?
agree, yeah. When you say forking is 10 points, you mean for the extra credit since it's not on the exam? Forking is on the exam. Forking is on the exam. Hold on. I'm gonna check after this. I'm gonna check after.
Somebody
after,
check, bro, because I can't. I'm recording. You can check.
Somebody check. Yeah, somebody here. I'm not screen sharing my Chrome tab, right? Here, I'll just look right now. I'm almost 100% sure that it's what is it called? Yeah, forking's on here. Forking is on here.
Yes. Okay.
Forking is on here. You're gonna need. It's
Yes.
gonna be very similar to the problem Cameron made. Forking is on here. It's on the extra credit, and it will be on the exam. It's on the exam one practice. Like, guys, come on.
it.
What's on my Chrome tab? Don't worry about it. I think it's around. Yeah, like for the test. Okay, hold on. I'm gonna say this right now. For the test, it'll be between 50. It'll be like split 50 points. So it'll probably be around 25 points. For the extra credit, it is worth 10 points for your test if you get the extra credit. Another thing about the extra credit is that it's all or nothing. You either get it or you don't get it. There's no partial for the extra credit. Will the forking be on the exam be similar to the extra credit? It'll be generally very similar.
Oh, and you can't go over 100 points. Okay, so if you get 100, or if you get like a 95 on the exam and you get 10 on the extra credit, you'll get 100. You can't. You don't get 105.
Another thing, I mentioned this earlier, but there's no copy and pasting on the
No,
Moodle.
you can't bank your points.
There's no there's no copy and pasting on Moodle. There is no like highlighting. I think while Cameron is doing it, there's no Command Z either, or Control Z, undo, whatever. I actually didn't remember that not being there, but I guess that's not there either. So just keep that in mind when you're programming, that there's not going to be stuff like that.
No, bro, you don't even have to do that. You don't even have to type CN or anything. He's gonna give you everything, man. I'm telling you. He's gonna give you every single thing. You don't have to CN. You don't have to read from a file. You just take the data he gives you and you just move it into a thread function and move it out. That's it.
Cameron, they're asking if their exam is in the same room as their class. For me,
Yeah.
my exam was in the same room as my
Yeah,
class.
it's in 103. SEC 103.
As somebody who's never used Moodle to do a test, what should I know? Like I said earlier, you can't copy and paste. You can't highlight text. You can't undo, Control Z or Command V or Command Z. Make sure your laptop is charged. Oh my God, there's like 3 people last semester when I was sitting next to them. Their laptops died or shut off. Make sure your laptop is charged. Yeah, there's no undo. I'm pretty sure there's not. If your laptop battery is bad, sit on the row that's closest to the wall, so you can use the socket, or or I believe there's some on the front. I forget. Are we gonna go through theory or just programming? Wait, are we going through theory as well, Cameron?
No. I think there's too much. There's over like 200 questions that they could get. I would say just stick to the PowerPoint, stick to your thing. We're gonna go over opcodes. Everything we're going over today is worth about 50 points. So if you just put the notes on your cheat sheet, you'll get the theory 100% correct.
I'll say this. Oh my bad.
No, go on.
I was saying for the theory, right? I know that's a big worry for a lot of people because obviously it's half the test. But here's the thing. The theory is mainly multiple choice. There's some stuff like opcodes and fill in the blank related things. But for theory, just pure theory, what I would do is if you were taking notes in class and attending Rincon's lectures, which you should have been, look over your notes and jot down the things that you're going to think that you have to know or will forget on the exam. When I took it, our cheat sheets were a little bit different, but it's the same principle. It's mainly just stuff that you think you're going to forget or don't know. Yes, there's a lot of content, but we compensate that because you have 2 sides of the cheat sheet and you can use. Better yet, give us a real cheat sheet, give us the answer. Another thing, this is new to this semester, you guys have to have the Safe Exam browser. That's part of Moodle, so go check that right now if you haven't. Yeah, Rincon, I was about to mention that. Thank you for putting that there, Lil Ramen. But Rincon will post like hey, on chapter one, go through these slides if you want to review for that on chapter four. So if you're weak on a particular chapter, that's definitely something you should look at.
Let me email
Email him.
Rincon real quick. Hold on. I'm gonna email him and see. He told me 103 today, so I think he just made a typo. But yeah, go on. Sorry.
No, you're good. Just other general stuff in the test before we go over opcodes. There will be, I believe, an attendance sheet you'll have to sign. So make sure you have like a pen or pencil on you to sign that. Make sure your laptop's charged. Make sure you have the safe exam browser. Stuff like that. Really basic over stuff. Really basic stuff that like you should have down by now. Can you put the completed code for the problem you just said? Yeah, I got you. Let me do that right now.
Okay, I just messaged him. It's kind of late.
Okay, if anyone has any other questions for multi-threading, let me know right now, like the next like minute, because it is getting pretty late, so we want to move on.
You just
Yeah, if you're
charge it.
yeah, just charge it. I would try to sit close to the wall. This is the
I think like for that, what is it, SEC 103? There's like plugs on the wall, but I mean, if you think your laptop is one of those like, you know, where it says 7 hours or whatever, and it's like gonna die in like 30 minutes, just sit close to Rincon in the front. Just tell him that, and he'll definitely help you out. Yeah, and also like I know we didn't really say this much, but Rincon is super lenient on the exam. So like if you have a question in head, even though it could sound like the dumbest thing to you in the world, ask him. Like he will probably, excuse me, he will probably just give it to you.
Oh yeah, another thing about questions. We can answer your questions, but they have to be syntax based or instruction based. So like if you're asking us how to dereference a pointer, we can't tell you how to do that. Or if you're asking us how to like how do I iterate or whatever through something, we're not allowed to tell you that. But like if you have a syntax error, we can help you like fix it. Or if you don't understand what the instructions are asking you, we can do that too. Yeah, we can explain the whole question like to you if you want and everything. But yeah, make sure you know how to dereference a pointer, by the way, or you're gonna
I almost
fail.
forgot that.
Like you will fail this class if you don't know how to dereference a pointer.
100%, yeah.
All right, I'm gonna get opcode started in about like 2 minutes, just so that we don't go too
Yeah.
overtime here. But
I think you could start now. It's fine.
Just yeah, go ahead and
all right,
start on it.
Start now.
let me go ahead and. Oh my gosh, my PC is overheating. Okay.
Dude,
And I believe
if you figure out how to do this without dereferencing a pointer, I'll just give you 100 on all your homeworks. Like I swear to God, I will.
All the tests, yeah, 100%.
Oh god.
Can you guys see my stream as well? I'm streaming. It might be a little bit like wide, but
Okay, I'm getting like a echo thing.
To mute the stream. Mute Ollie's stream, or stop watching it.
Okay, or stop watching it. Yeah, that's fine. Um, yeah, that's fine. Hopefully, you guys can hear me. Okay, let's get started with the opcodes. Okay, so you will see, and yes, you will 100% see an opcode question on your exam. And this question will be around, I believe it's around like around 10 points. So definitely do know it. It's part of your theory questions. But yeah, let's get started with this example. So you will see something very similar, if not identical to the wording of this question right now. And it says to calculate the following parameters for this hypothetical computer system with these given features. Okay. And for this example, we're going to do a octo notation. But before I kind of get to the actual questions, does anybody here know how many bits are in an octo digit? 3. Good job. Yes,
3.
that is correct. So, yep. I'm going to go ahead and highlight this in red just because it's really important to know. So, okay. Binary is 1 bit, of course. And then octo is 3 bits. And hexa is 4 bits. Okay. You have to know this. And I would highly recommend you Okay, six, maybe seven. Nice. Okay, I will highly recommend you to write this in your cheat sheet, um, just so that you don't forget. Okay. And then next up, you will be given a condition where it says the IR is equal to opcode plus memory address. And I'll get to what this means in just a second. You're also given here that the IR is 12 bits. The program counter PC is equal to 3 octal digits. Um, and also, I think it's pretty worth mentioning that the IR is also the memory word size, which is just kind of a fancy way of saying memory address. So, or excuse me, sorry, I'm mixing this all up.
Let me
I'm
interrupt
sorry.
you real quick. I'm sorry. It's in
Yep.
SEC 103. He made a typo, so it's in 103. It's the same class you always go to. Say go to the same class you've always go to. Okay. He's gonna resend an email, but yeah, just let you know.
And sorry for that little screw up here, but the program counter is just a very fancy way of saying memory address. Okay, just so that you know. Okay, so with all these givens, you'll be prompted like probably not going to be all these questions, but you're going to be given some kind of question that's related to like these four different things. Okay, so let's get started with the first one. So it says the number of different opcodes. So first, what I like to think about this is like the combinations of all the opcodes that you can get. And the way that we can get opcodes from these givens right now, and if we're to actually take a look at the second condition where it says IR is equal to opcode plus memory address, I'm going to actually just copy and paste it here just for the sake of clarity. So we can say IR is equal to opcode plus memory address. And we're trying to get what the opcode is right now. Okay. Now, in the given, it says that the IR is equal to 12 bits, right? So we can just kind of plug that in. So 12 bits is equal to, we're trying to find what opcode is, right? Plus the memory address. Okay, and what is the memory address? Well, it says the program counter is equal to 3 octal digits. And I just mentioned to you earlier that this literally just means memory address. Okay, you don't have to try to understand what it means, what it does. It's just memory address. So this will be plus 3 octal digits. Okay, hopefully this is pretty sensible so far. Okay, so next up, like I mentioned earlier, I asked you guys what or how many bits are in an octal digit, right? And we answered that it's 3. So if there's 3 bits in a single octal digit, then how many bits are in 3 octal digits? All right, let me kind of rephrase that question. So yes, the answer is 9. Yeah. So if there's 3 octal digits, right, and there's 3 bits per digit, then it will be 9 bits, right? And just to kind of put this in a separate color, this is what color should I use? I don't know. Let's do like green or something.
Purple.
So okay, purple is fine. Don't really matter. But so this is calculated by 3 octal digits times 3 bits per digit. Okay, that's how you get 9. Hopefully that's not too bad to understand. Okay, so then what is opcode then? Right? Then it's simply is equal to 12 bits minus 9 bits, right? Which is 3 bits. Okay, and some of you might say, okay, we're done, right? It's just 3 bits, and that's the answer. No, so not that simple. This is telling you how many bits are in each opcode. Okay, but there are how many different opcodes are there? So this is kind of the formula that will highly encourage you to write in your cheat sheet. Is you have to do 2 to the power of how many bits are in the opcode. So that's why I kind of worded it like the combinations, right? The combinations of how many opcodes you can have, which is 8. That's the 8 of different opcodes, just to be really specific. And this is the answer. So definitely have this somewhere in your cheat sheet. You're probably going to forget. So there you go. Any questions on this? We don't show our work, right? No. So this question on the exam, you're literally just going to see it as, and it's going to be one little rectangular box where you have to submit your first response numbers. You punch it in. If it's equal to the right answer, then you get full points on it. Otherwise, you don't. That's it. Yeah. Okay.
Yeah, this is like
Of
free
course. So
response, kind of.
yeah. Mhm. And yes, I will share this document after I finish. Do you recommend bringing scratch paper, or is it low-key a waste of time? Yeah, definitely have scratch paper on you. I would definitely recommend that. But anyways, moving on. What is the memory size in bits? This is probably the hardest one. And I will try to explain this as slow as I could, just so everyone gets this. So, how do we calculate the memory size? So first, we get that the what is it? The actually, give me 1 second. How do we calculate the memory size again? Okay, so we get that the memory address is the program counter, which is 3 octo digits, right? So let me just kind of rephrase that real quick. So the program counter, which is memory address, is 3 octo digits. And we already said earlier that this is equal to 9 bits. And if you would like that calculation again, is right here. Okay? So think about this as the combination again thing. That's kind of the analogy that I made, right? How many different combination of memory can we have? Right? Then it will be 2 to the power of 9 bits, right? Which, what the heck is that? I think it's 512. Yes. So it will be 512. Think of this as like the number of memory. Okay. And once we get this combination, or the combination of memory, if you will, right? How many bits are in each memory word size? And it's given to you in the question, right? It says the memory word size is equal to 12 bits. And I'm gonna go and actually repeat that here. So it says memory word size is equal to IR is equal to 12 bits right here, right? So if there's 12 bits in each individual memory combination, how much memory size is there in bits in total? Right? Then it will be as simple as, let me go ahead and put that in red. It will be 512 times 12 bits, right? Which will be, I'm pretty sure it's 6144. If someone wants to fact check real quick. But that will be the answer. So memory size in bits. And that will be the answer. I'm probably gonna need the other TAs to help me out a little bit in chat, just
You're
because I'm
good.
seeing
Yeah,
like,
yeah. Just
yeah,
showing
there's
me.
like a million questions, but yeah. Any questions on this? And feel free to speak up. It's probably gonna be easier for me to answer your question, so I don't skip it. Yeah, this question is gonna be around. It's like 6 or 7. No, I'm kidding. I think it's around like 10, something like that. Sorry, it's late, guys. It's really late. I'm sorry,
It's 9 o'clock, bro.
Instead of
bro.
octal, if we're given like hexa, is it the same process? But just keep in mind hexa is 4.
Yes. So very good question. We'll get to. Oh, it's very colorful. Yes, it will be 4 bits per digit, and I'll show an example since we'll have a little bit of time left as well for an hexa notation example as well. So I'll get to this one in just a minute. But if there's no questions on that, I will get to memory range, and this one is probably the easiest one. So memory range, how this works is that you basically look at the memory address and you determine how many digits are in the range. So what is an octal notation range, right? It goes from 0 to 8, right? And how do we know that? Well, you can just write this in your cheat sheet. And let me actually go in and write this down. I'll write it down here. So I'll put this like as a, we'll go with purple. So binary, the range is, well, you should know this already. It's just 0 to 1, right? And then what is octal range? Well, it will be 0 to, no, it's 0 to 7, excuse me. It's not 0 to 8. And then the hexa range, it will be from 0 to F. And you probably learned this back in architecture or data science, or I don't know, but now you know. Okay. So what is the memory range in this hypothetical parameter or a computer system then? Well, then you look at the memory address and you say, okay, so the memory address is 3 octo digits. Okay. So if it's 3 octo digits, then it's literally just going to be 000 to 777, and you're done. That's the answer, right there. Okay, so since there's 3 octo digits in memory address, that's the answer right there. Any questions on that? Super straightforward.
Show them an example of like if it's hexa or binary as well, just to make sure.
Sure. Yeah. So if it's hexa, well, if there's 3 hexa digits, let's put this in like green or something, just so that I don't confuse people. Let's say if it's like if there is 3 hexa digits instead. Okay, I actually hate that color so much. I can't see.
Do like a maybe like a purple.
Good call.
Okay. Any questions on this? Pretty straightforward, right? All right, so what is a total data range? Well, pretty simple. So you basically combine the opcode and the memory address. So your total data range is just going to be your IR, essentially, right? So just to combine the opcode and the memory address, it will just be, put this in red, it will literally just be 0000 to 7777, and that's it. Any questions on how I got this? Let me put this in a different one. Or actually, I should probably explain this a little better. Sorry. So, yeah. Like, I should definitely explain this a little better. So, the IR, that was actually, I don't know why I did. I'm getting so tired. I don't know why. So, the IR is equal to opcode. No underline, please. So, the IR is equal to opcode plus memory address. Okay. So, the IR is equal to um, opcode, which is 3 bits, right? And that's what what we calculated right here. So 3 bits. So 3 bits plus 9 bits, right? I don't know why I just did it this way. IR is literally just 12 bits, literally given the question. Okay. So if the IR is 12 bits, then how many octo digits are in IR? Right? So then this will literally just be 4 octo digits, right? Because there is 3 bits per octo digit. Let me just put this in purple just because Cameron likes purple. Does that kind of make sense? Yeah, so if there's 4 octo digits, then what is the range? Well, it's just, there it is. It's 0000 to 77. Just 4 of them, four octo digits, and that's it. Yeah, basically, yes. Can you zoom out the Word doc so I can, you'll get this doc. Like, I'll download it and I'll, just so everyone can see it. Yeah.
Dude, I used to have this
Can there
thing
be
I
5?
wrote. It was like all of the formulas for these questions they're having. I need to find it. It's gone, but if I could send it, like you could definitely put it on your cheat sheet. It'll help.
For sure. Yeah, for sure. Any questions on this? I'll show another example just because we have like 15 minutes. But why are we doing octo range instead of hexa range? Because that's what the question's asking. So it says octo notation for this question specifically. Okay, but let's go ahead and do one with hexa notation just because we're getting quite a lot of questions. Binary, I don't want it to do binary just because it's pretty simple. But let's go ahead and do a hexa one. I'm gonna delete all the answers real quick. Okay, that's a huge number. What the heck? What is all of this? I'm just gonna move this down. Don't worry about that. Yes, this is gonna be the last thing we're going over. So yeah. Okay. So same deal right here. We're getting the hypothetical computer system with these following numbers, okay? So first it's written in hexa notation. Okay, so how many bits are in 1 hexadigit? 4. Good job. So there's 4 bits per hexadigit. Okay. And then we're given that the R is, you can always assume it's going to be true. Like this is going to be always going to be in the given. And the R is 20 bits this time. Program counter is 4 digits. And the memory word size is going to be equal to the IR once again, 20 bits in this case. Okay, so how many different opcodes are there? So first, we are given that the IR is equal to opcode plus memory address. Okay, that's in the given. The IR is 20 bits, is equal to opcode. That's because that's what we're trying to calculate, and is plus 4 hexa digits. Okay, so how many bits are in 4 hexa digits? Can anybody tell me? How many bits are in 4 hexa digits? 16. Good job. Yes. Why is it 16? Because, let's do this in purple just because it's 4 hexa digits times 4 bits per digit. Pretty simple. Okay, I wouldn't use 4 squared, but that's kind of
No,
terrible.
I
But,
don't use four
yeah,
squared.
please do not, don't know. They could be different numbers. Yeah. That is a horrible advice. But anyways, so what would opcode in this case be? Well, it would be, why is this? What is happening? Blue. And the opcode would be 20 bits minus 16 bits is equal to 4 bits. Okay, and are we done? Not quite, right? We need to use that little combination thingy that we talked about. So this will be 2 to the power of 4 bits, right? Which will be 16 different, or number of different, I can't spell, opcodes. Okay, and that would be the answer. Any questions on that? Okay, just to kind of speed this up a little bit. Memory size in bits. So how do we get the memory size? Well, we just look at the memory address once again, right? So the memory address, we have to try and calculate how many different combination of memory there is. So, well, there's 16 bits, or let's just do this again. So the memory address is equal to 4 digits, which is equal to 16 bits, right? Hopefully I don't have to explain why that is again. But so 16 bits, how many combinations of memory is there? 2 to the power of 16 bits. And that explains why that's such a big number. What in the heck is this? 2 to the power of 16. That is 600, yeah, whatever that is, 65,536. Okay? And on the exam, by the way, you're not gonna see, please, like it's not gonna be this big. But yeah. So once you get the, we'll just call it number of memory, if you will. If there is this many memory and each memory has 20 bits, so what's the total size? Right? The total size will be, here, let's do this in red. The total size would be 65,536 times 20, right? Which is yes. I don't know. 65. Just do this on my calculator real quick. It would be a million. That thing right there. Memory size in bits. There it is. Okay, and once again, you're not going to get this big of an exam. You do not need to do like this hard of a math, and if you do, well, you have a calculator anyways. So, memory range. Okay, we're given that there is 4 digits of memory address, and there's 4 hexa digits, right? So, just to reiterate what I just said, 4 hexa digit, or okay, memory address is equal to 4 hexa digits, right? So the answer is literally just simply 0000 to FFFF. Now, why is it 0 to F? Because this is in hexa notation. Yes, binary is just 1 bit. Exactly. So it would be 0 to 1. It's as simple as that. Any questions on this part? Okay, and then the total data range. So let's go ahead and go over the IR again. So what's the IR? The IR is 20 bits, right? if it's 20 bits, how many octo or how many, excuse me, how many hexa digits are there in 20 bits? Okay, don't, oh my god, the answer is still there. Okay, all right. How many um hexa digits are in 20 bits? Right, it will be 5. Yeah, someone answer it. So this will be 5 hexa digits. Okay, because it's 20 divided by 5, right? I'll put this in purple just because Cameron likes purple. Okay? Or 20 divided by 4, excuse me. Yeah. So if there is 5 hexa digits, then what's the range? That's the range right there. Boom. Pretty straightforward, right? Hopefully. Okay, let's go ahead and do one with binary just because we're getting a lot of binary questions. But and don't worry, I will send this document in chat after I finish. Sorry, there's like all these given answers. Let me format this doc better just so that it doesn't look like crap. Okay, that's already at the top. Okay. If you have any question in chat, I probably missed it. So if you have any questions right now, you may speak up as well. I don't know what you guys are saying in chat, but anyways, binary notation. Now, how many bits are in a binary digit? Well, it's just one. So, because binary is as simple as 0 or 1, right? So, 1 bit per binary digit. Okay. Same deal, IR is equal to opcode plus memory address. And this is actually, this time is a little bit different. We're given that there's 2 opcode digits this time instead of your regular IR. Okay, it's pretty much the same thing. It's like super simple algebra, right? You just plug in things and then it works. Memory address is equal to 3 bits, and then the memory word size is still equal to the IR. Okay, so far so good. Now we're asked what the number of different opcodes there are this time still. So these 4 questions are still going to remain the exact same. It's just going to be, you know, exact same. I don't know why I said that, but anyways. So IR is equal to opcode plus memory address. Okay. Now we're trying to find. Oh, okay. Well, for this one it will be a lot simpler, right? Because we're already given that there's 2 opcode digits. Okay, we're already given that there's 2 opcode digits. So if that's the case, then what is 2 opcode or what is 2 binary digits in bits? Well, it's literally just like 2 binary or okay, hang on. Opcode is equal to 2 digits, right? Which is literally equal to 2 times 1. Well, if you really want to do this math, I'm just showing it for the sake of showing it. So binary digit uh, bits per binary digit, right? And this will be just equal to 2 bits, right? So the opcode is 2 bits. And what was the formula to get the combination, quote unquote? 2 to the power of 2 bits, which is 4 number of different opcodes, right? So for the sake of clarity, I'll just say like the 2 bits as well, right? Is there any question with this, by the way? It's like, I know this might be more complicated than it should be, but because there's only 1 bit per binary digit, so digits and bits are literally exact the same wording in binary notation. So it's 2 bits per opcode. Yes. That's correct. Yes. Because opcode is equal to 2 bits, yeah. Okay, pretty straightforward. What is a memory size in bits? Now we're given that the memory address is 3 bits, right? And how do we get the combination of memory again? Well, it's just 2 to the power of so 2 to the power of 3 bits, right? So this will get you the number, or so this will be 8, right? This is the 8 number of memory, if you will. Okay? And then if each individual memory is equal to, okay, well, in this case, we're not given what the memory word size now is. So we have to calculate it. Okay? So if the IR is equal to opcode plus memory address, okay? So this will be opcode is 2 bits plus what is memory address? 3 bits, right? So this will be 5 bits, which is also equal to the memory word size, right? Because IR is equal to memory word size right here. It's in the given. So I'm actually going to separate this just so for the sake of clarity. So if there's 5 bits per memory and there's 8 of them, then what's the total? Right? So if there's 5 bits per memory and then there's 8 of them, then it will be 40 bits in total, right? So 40 memory size in bits, and that's it. You're done. That's the answer right there. Boom. If we're too dumb to do the math, can we ask the TA? You will have a calculator.
What? I can't tell if you're being serious, dude.
Like, dude, you will.
You
will
want
have
us
a
to do the math?
Yeah.
That was a stupid question. Don't say that again.
Anyways, so yeah, I mean, if you don't know your 5 times 8, good luck. Memory range. So, um, what's the memory range? So there is 3 bits, which is 3 digits, right? So I'm just going to write this very explicitly just to not confuse people. So the memory address is equal to 3 bits, which is just equal to 3 binary digits, right? And if there's 3 binary digits, what is the range? Well, it's just, there it is, right there. Boom. 3 zeros to 3 ones, because we're in binary notation. And then lastly, total data range, which, so what is the IR? The IR is equal to, we already calculated right here. I'm just gonna literally copy and paste this. Okay? And then what is 5 bits in binary notation? Well, it's just 5 binary digits, right? And what's the range of that? Well, just gonna smash my zeros and ones real quick on my keyboard, and there it is. That's right there. That's your total data range, and voila. You get your free 10 points, and then you win the exam, and you get an A in the class. There you go, right there. Any questions? Just gonna go ahead and format this a little bit better. I don't know what any of this is, so I will just boom. Forking examples. Oh yes. Average access time. I should probably explain this. We have like 5 minutes left. Okay. Just for the remainder of the time, I forgot that there's also a math question on your exam, but this is super simple.
Yeah, this is where you'll have to
so I'll
rearrange
just-
the equation. This is where you might need a
Yes.
calculator, which he should allow you to have an online one. I'll talk to him tomorrow during y'all's extra credit.
I'm honestly kind of lazy, so I'll just kind of explain the answer of this because it's super freaking simple.
I mean, just give him the formula.
Yeah, the formula is, where is it? Yeah, there it is, formula. So write this in your cheat sheet. This is going to be one of your, how many points is this question? Like, yeah, 5 or 10. I was going to say the exact same, something like that. So it's like pretty small. But this question is literally just simple algebra, okay? It should be in your slides as well, PowerPoint slides, but this is the formula for this question, okay? So let's just go over like one example, since we don't have much time left. So let's say in an example where the memory access time is 50 milliseconds, the L2 is 400 milliseconds, and the miss ratio is 20%. Now, so if the miss ratio is 20%, how do we get the hit rate? Well, it's just whatever 1 minus 20% is, right? Okay, which would be 80%. So we're asked what the average access time is, and the formula is literally right there. So you just kind of literally have to plug this in. It's as simple as that, right? So percentages, if you're gonna ask us what a percentage is in the exam, I'm probably gonna kill you. No, I'm just kidding. But so 80% is 0.8, right? 0.8 times 50 milliseconds plus 0.2 times the sum of L1 plus L2, which is 450 milliseconds, and you just get the average access time, whatever this number is. So probably, do have a calculator for this. Pretty straightforward. And yeah, and so sometimes, right, this question could be rearranged. We don't necessarily have to ask you what the average access is. You could be given what the average access time is, and you might have to calculate, what the L2 access time is. Well, hopefully you passed your Algebra 1 back in high school. But, you can just plug everything in and just calculate for what L2 is. And boom, shakalaka, there it is. It's right there. Okay, so these are these literally should be like free. You really should not get any points off of this unless you punch the numbers wrong in the calculator. What's a calculator?
It's short for calc. It's slang, guys. It's short for calculator.
You should have Rincon there, question.
Yes, we're gonna give. Look, I'm. We're gonna give you seconds, okay? We're not giving you pictoseconds, or pico or milliseconds. Like I don't. You'll be fine, okay? You don't have to worry about.
Pico is like what? It's like 2 to the power of like -12.
That's what I'm saying, bro. I think he's rage baiting, bro.
Oh my god, pico is a food. You guys are like interesting. Okay.
This is the most active class
Right,
I've ever had, for sure.
True. You guys are very lively. Okay, any questions on anything we've gone over today? So we've gone over forking, multi-threading, opcodes, and then a little bit of Algebra 1. So other than that, you should be great. You guys will do awesome. I believe in all of you guys. Please
Bro, I
take
promise it's
full
gonna be so
advantage.
easy, bro. Like, trust me. Like, you guys are here. If you understood at least a little bit and you practice just a little bit before tomorrow, you're gonna be just fine, okay? I know. Let me. I'm gonna go ahead and we'll tell you tomorrow about the calculator thing, okay? You won't need it for the fork, but we'll tell you before your exam on Thursday, okay? Dude, how long is I'm gonna